investor invests $100. Each month, the investment has probability 0.5 of increasing by $1.1 and probability 0.5 of decreasing by $0.9. The changes in price in different months are independent. Calculate the probability that the investment has a value greater than $91 at the end of 100 months. So let xk be the change in month k. Then they say that the change, there's a probability that it will increase by 1.1 with probability 0.5, or it could decrease by negative 0.90 with probability 0.5. So that's what we have about xk. And therefore, E of xk would be 1.1 times 0.5 plus negative 0.9 times 0.5 equals 0.1. And E of xk square, we square these, 1.1 square with probability 0.5 plus negative 0.9 square times 0.5. That's 1.01. And from there, we can get variance of xk, which will be E of xk square minus exk whole square. So 1.01 minus 0.1 whole square equals 1. And now this is the information about change in 1 month. xk was the change in one of the months, let's say month k. Now we are interested in the total change over 100 months because overall we want that the investment value greater than $91 because we started with $100 and we want the final amount to be greater than $91. So that's the same thing as saying that the total change is greater than negative $9 because if the final amount is 91 and the initial amount is 100, then the change is 91 minus 100 equals negative 0.9. And so we'll come back to this again later in the problem. Right now, my point is that we are interested in the total change. So if xk is the change in month k, then the total change will be the sum of all those changes over the 100 months. And let's call that total change be x. And now we use the central limit theorem. We don't know how this change is distributed, but since we are talking about 100 total changes, which will happen in 100 months, and that is greater than 30. So we use central limit theorem, which says that the sum of greater than 30 identically distributed independent variables, if each of them has mean, if each of the variable has mean xk, then the mean of the sum will be n times mean of each. N is the number of variables, which is 100, and mean of each of the xk was 0.1. So the total mean is obtained by multiplying 100 with 0.1, that's 10. And then the second part of central limit theorem says that the standard deviation of the sum, remember x is the sum of all these, that's equal to square root of n times the standard deviation of each of the variables. So square root of 100, and since the variance of each variable was 1, so standard deviation will be square root of 1, and this gives 10. So now we have the mean and standard deviation of the sum, which according to central limit theorem is normally distributed approximately. And we can now use our normal formulas. So as we talked before, that since we started with $100 and we want the amount, we want the probability of the amount of the amount to be greater than 90. Okay. We need, let's say we need the probability, or we ought to calculate the probability of the amount to be greater than 91 at the, and we have to calculate the probability of the amount to be greater than of the amount being greater than $91 at the end of 100 months. This means that we are talking about the total change over the 100 months should be greater than negative 0.9, because we want the final amount to be greater than 91. And a final amount of 91 means that the change is 91 minus 100. Remember, 100 was the initial amount. So a final amount of 91 means change is negative 9. So a final amount greater than 91 means change has to be greater than negative 9. And we are calling that total change to be x. So we need the probability x to be greater than negative 9. Therefore, we need to change negative 9 into z-score. So we use our formula, negative 9, and the mean of this total sum was 10, standard deviation was 10, so that's negative 1.9. So probability x greater than negative 9 is the same as probability z is greater than negative 1.9, which from the tables, okay, so we should have done another step. Z greater than negative 1.9 is the same as probability z is less than 1.9 by symmetry. And that from the table, if you look at 1.9, it's 0.9713. And the answers are to 2 decimal places. So this rounds to 0.97, that's choice E.